Welcome to our deep dive into optimizing parallel processing with Joblib. Today, you'll learn how to leverage Joblib's capabilities for efficient data processing, enhancing your Python skills for superior performance. Hello and welcome to our channel. Did you know that Joblib can cut your data processing time in half? In this video, we're going to explore how Joblib can revolutionize the way you handle computational tasks in Python. With parallel processing becoming increasingly crucial in data-heavy applications, understanding Joblib is a must for any professional looking to optimize performance. Over the next few minutes, we'll delve into everything from setting up your Joblib environment to avoiding common pitfalls. Stay tuned to learn how you can work smarter, not harder.
Parallel processing is the simultaneous execution of multiple processes. It's like having several cooks in a kitchen, each preparing a different dish. Unlike sequential processing, where tasks are handled one after another, parallel processing allows multiple tasks to be executed concurrently. This is particularly beneficial in data science and machine learning applications where large datasets need to be processed quickly. By leveraging multiple cores of your CPU, you can significantly reduce processing time. Real-world applications include rendering graphics, processing scientific data, and running complex simulations. To get started with Joblib, you'll first need to install it. This can be done easily using pip. Simply type pip install Joblib in your command line. Once installed, you'll want to ensure your environment is properly configured. This includes setting the right environment variables and integrating Joblib into your existing Python projects. You can test your setup by running a simple script that uses Joblib for parallel processing. Ensuring everything is configured correctly will save you a lot of headaches down the line as you start implementing more complex tasks.
Joblib offers several parallel backends, each with its own strengths. The most common are low-key, threading, and multiprocessing. The low-key backend is often recommended for CPU-bound tasks as it allows for memory sharing. Threading is suitable for I/O-bound tasks, while multiprocessing provides a good balance but can have higher overhead. Choosing the right backend depends on your specific needs and the nature of your tasks. It's also easy to switch between backends using Joblib's API, allowing you to experiment and find the optimal setup for your projects. Let's walk through a simple example of implementing parallel processing with Joblib. We'll use Joblib's parallel and delayed functions to execute tasks concurrently. Imagine you have a function that processes data. By using parallel, you can run this function simultaneously across multiple data inputs. Here's a small code snippet to demonstrate. From Joblib import parallel, delayed results equals parallel n underscore jobs equals for delayed my underscore function I for I in data. This code will distribute the work across 4 CPU cores, processing each data item concurrently. Be sure to test and validate your results to ensure accuracy.
Even in parallel processing, exceptions can occur, and handling them effectively is vital. Common exceptions might include memory errors or issues with data inputs. You can use try-except blocks within your functions to catch and handle these errors gracefully. Additionally, logging errors is crucial for diagnosing issues without interrupting the entire process. Joblib allows you to continue executing tasks even if some fail, ensuring that your processing completes as much as possible. This robust error handling capability is one of the reasons Joblib is so powerful for large-scale data processing.
To truly optimize your parallel processing tasks, performance benchmarking is essential. Start by measuring the time it takes for your tasks to complete using Python's time module or more advanced tools like cProfile. Once you have baseline data, you can experiment with different numbers of jobs, backends, and optimizations to find the most efficient setup. Look for bottlenecks in CPU or memory usage and adjust your code accordingly. Remember, optimization is an ongoing process. Keep analyzing performance data and refining your approach to achieve the best results.
While Joblib is a powerful tool, there are common pitfalls to be aware of. One of the biggest is memory leaks, which can occur if your tasks hold onto resources longer than necessary. Ensure you're managing memory efficiently by cleaning up resources after tasks complete. Another issue is inefficient task management, where tasks aren't evenly distributed across processors. Use Joblib's features to manage workload effectively. Also, be mindful of task dependencies, ensuring that tasks are independent where possible. Following best practices will help you maintain stability and performance in your parallel processing tasks.
For those looking to push the boundaries, Joblib can be integrated with other Python libraries to handle complex workflows. Whether you're working with large-scale machine learning models or intricate data flows, Joblib can be customized to suit your needs. You can control how tasks are distributed and executed, allowing for fine-tuned performance. Additionally, advanced error handling strategies can be implemented to ensure robustness. By combining Joblib with libraries like NumPy or scikit-learn, You can create sophisticated processing pipelines that handle massive datasets efficiently.
Congratulations on completing this deep dive into Joblib. You've learned how to set up and optimize parallel processing, handle exceptions, and avoid common pitfalls. Remember, mastering Joblib is an ongoing journey. Engage with the community, continue experimenting, and adapt your approaches as new challenges arise. We'd love to hear about your experiences. Comment below and share your insights. If you found this video helpful, don't forget to like and subscribe for more content like this. Until next time, keep pushing the boundaries of what's possible with Joblib.